All right. Hello, everyone. I'm Kristen McConnell. I am a therapy physics resident at UC San Diego. And as the title suggests, I'm going to talk about our advanced camera optimization installation that we have and sort of how we tested it, what we've seen. So from the surface, the world before ACO doesn't look a lot different than the world after it, but under the surface, it definitely does. Sort of as you can see from what Paul showed, we had similar results, and we'll go into that. I'm going to talk a little bit through how we use AlignRT at our clinic, what testing we did for the ACO, and then sort of the results that we've seen. So at UC San Diego, we use AlignRT as an integral part of our daily clinical workflow. It's an important tool that we use both for setup and monitoring during a lot of our treatments, specifically for our HyperArc treatments. So for SRS, we now deliver all of those treatments using HyperArc, and we do monitor during the entire time. We use the open face and compass mask. We do all of ours frameless, of course, and we do it bite blockless. And we use it for DIBH setups on the free breathing scan, as well as monitoring during DIBH. We do tattoo-less setups for the cranial cases. So we like to use it just to get rid of all the rotations to start with, and then we can just do our KV orthogs and our CBCT, and we're good to go usually after that. And so we don't have a lot of extra imaging that comes with that. It is hooked up to our gate CT, or our CT is hooked up, and then we also use it to monitor during any high-risk cases that we have. We have 4 machines at Moore's Cancer Center, so that's our main site, and 3 of those machines have AlignRT installed on them. They're all running at least 5.1 version, which of course has the ACO, and then our SRS TrueBeam has 6.1 on it, so we're sort of testing that out right now. On the 2 TrueBeams, we do very similar stuff or treatments with them. But SRS is exclusively done on that one TrueBeam with the other one as a backup. And then we have a Halcyon in which it has the 2-camera system installed, and we use that to set up some of our brain patients. So we just use we'll talk about the Halcyon in a second, but we use it in a little bit different of a way. So like I said, the 3-camera system is installed on our 2 TrueBeams. We don't use the manual head adjuster because we do have the 6-DOF couch. And we have the TrueBeam 2.7 version, so that includes HyperArc. And then for the 2-camera system, we have this for the Halcyon. So this is sort of an interesting thing if you don't have a Halcyon. It's kind of an interesting beast to play with because as a physicist, you don't really get to touch a lot of the things you're used to touching, and you can't set up SSDs, and so everything gets set up at the virtual ISO center. So it's a lot more like a CT scanner. And so the camera calibration takes place at virtual ISO, and so does our patient setup. And so we use the AlignRT on the Halcyon, and it really has helped our workflow. The Halcyon's already very fast. We get a lot of patients through on this machine, but we use the AlignRT to set up the head patients right now. We're going to do more, but we're starting with head. And it takes away the rotational errors up front. So we don't have a couch that will provide rotational shifts. So we get those taken away first with the AlignRT, put the mask on, then we go do our cone beam and apply the translational shifts from outside the room. That way, no one has to come back in and intervene. And so that's really improved our workflow for the Halcyon. So I sort of talked through how we use AlignRT at UCSD, but I want to start before we go into the ACO by just talking about a couple research papers. This one's kind of interesting because it's relevant to the idea of how increased stability in monitoring has the potential to open different ways to improve our treatments. And so this study was performed at our clinic. They looked at different action limits, or how for a single ISO MET case versus a multi-MET with a single ISO case, how that affects the accuracy, and maybe should the limits at which you intervene be patient specific. And so the top graph that they show is if you have a single ISO and you apply some different rotations and some different translations, how are the DVHs affected? And you see, well, they're not affected too greatly. And the bottom is for multi-met single ISO. If you apply the same translations and shifts, those DVHs look a little different, right? And so that brings up the point that maybe these action limits should be patient-specific and you should be applying them in a different way. But if you want to do something like that, you need to have high confidence in your surface tracking and overall couch kicks, overall ranges, because you're just going to start getting erroneous deviations and just keep bringing your couch back to zero and cone beaming, and we don't want to do that. And so before the ACO, just like Paul was saying, we saw the same thing where, different couch kicks led to occasions where the surface imaging would indicate that there was these unacceptable deviations. And we also use the 0 degree as the ground truth, so we bring the patient back to zero. That interrupts our workflow, of course, with HyperArc, because it's all automated. So we have to break the automation, bring it back. And so then we'd end up taking an unnecessary cone beam. It's still a 0, or the patient hasn't actually moved. So kind of anecdotally, though, after ACO, we have seen better tracking with all those couch angles. There's always going to be this scenario where you have something like, a suboptimal isocenter location that the cameras can't really handle, or hair, or an ROI selection, as you guys were speaking about. But we have seen improvement so far. And there was this paper that came out about the time that we received the ACO. So we installed it in October 2018. These people looked at comparing surface imaging, specifically AlignRT, to ExactTrack and seeing how well those two corresponded. And what they saw was that they corresponded very well, and their conclusion was that they would actually be very comfortable just using the surface imaging. So that was promising as we went into our ACO study. And so we got the ACO, like I said, October 2018. We had some questions. We wanted to know, how would the ACO change our workflow? How would it change what our clinical deliveries looked like? So we started off using this head phantom, and we wanted to answer two questions specifically. How does the KV-CBCT delivery look like after the ACO? And then how does tracking during the HyperArc deliveries look when you have different isocenter locations in the head? So mid, left, right, anterior, and posterior isocenters. So the way we did this was we planned 5 different HyperArc cases using those 5 different positions. So as you can see here, and so we made these all in the HyperArc Eclipse. They were optimized exactly the same way as we do our clinical patients. And then we placed everything on the couch, aligned it using the AlignRT first, KV cone beam, got everything in the right place. And we'll take a look at what the KV cone beam data look like. So this is tracking as a function of ISO position during the KV CBCT. All the translational errors are shown on top, all of the rotational ones on the bottom. The different colors represent the different isocenters. So as you can see, I think the big takeaway from this is, one, we were able to track data the entire time, which hasn't always been a thing, at least for us. Sometimes during the cone beam, we would get errors that said no overlapping surfaces, and we couldn't acquire data, so we were kind of driving blind for a second. But here we were able to see data the entire time, and it doesn't seem to matter where the isocenter was for the cone beam. And so that was very promising. And if you want to look at numbers, here's the numbers that are associated with. So these are the 3D mag values, and they range anywhere from 0.13 to 0.15 millimeters, which is basically the same number, right? So during the cone beam, we were very pleased with the results we saw, and we were happy that we could actually measure during the entire thing. Now, the next thing I said we were interested in, of course, was the HyperArc. So for anyone that's not familiar with the HyperArc, it is fully automated during the delivery. So this is what the delivery looks like. When you go to plan it, you get the choice of very specific couch kicks and very specific arcs. So you can have a full coplanar arc or half of a coplanar arc, and then you can have a couch kick at 45, 315, 270, or 90, depending on sort of how it decides the workflow is most efficient. And when you go to set it up, depending on the isocenter, it'll let you know which arcs that you can use. So it looks to protect the patient, basically. So there's a little exclusion zone during the planning process, and you can move your ISO based on that. So that's how it works. We tracked during that delivery for all of those different ISO center plans. And so I'm showing the 3D mag plots of that. And the different colors represent the different couch kicks. So the blue is 0, the yellow is 45, let me see what color that is. The green is 270, and then the red is 315. And any of the gray is where the couch was on the move, so that was expected. And if you notice, some of them are in different order, and this is because the HyperArc chooses the order for you. So it chooses to deliver how it sees most efficiently. But visually, you can see from this graph that the 45-degree couch kick seems to be consistently providing what appears to be the largest deviations. And as Paul has talked about, it's very important to look at your couch walkout. And so these values have not excluded the couch walkout. So these are inherently have that in there. And it happens to be that we took a look at our couch walkout, and at 45 degrees, that is where our couch walks out the most. It's kind of interesting. And then these are just the values if you want to see numbers that go along with it. Depending on ISO, the 45 showed essentially the largest everywhere. So it didn't seem to matter which ISO it was always showing the highest. And then the last thing that we looked at was rotational tracking. So I know these are small, but you should notice the y-axis is just minus 0.3 degrees up to 0.3, and everything pretty much fits within those bands very well. So I think we really saw improved stability on this tracking as well. And so here's the numbers that are associated with that. They seem to range from minus 0.25 to 0.18, and pretty stable throughout all of our HyperArc delivery. Now, the one thing that is inherent to these results, like we talked about, was the couch walkout. And couch is known to move as you rotate, and that causes the surfaces to get misaligned. And if we are only trying to characterize the ability of the tracking and not the surface tracking plus the couch, we don't want to have those in there. And so we are going to try to subtract those. One thing that we looked at just to see initially what kind of magnitude we were looking at was this enhanced machine performance check. So this is something that comes with the new version of the TrueBeam. You set it on the couch and it runs basically a Winston Letts test. And so it adds this one value on there called the maximum positioning error. And that's shown on screen to be plus or minus 0.38 millimeters. And so we knew that it wasn't a huge effect from our couch, but that it is there. And the cool thing about this enhanced MPC that comes with this one is it tests all of our HyperArc angles. So since we only deliver that way, it's something that we're very interested in. And so the last thing, I mentioned that we're running 6.1 on our SRS TrueBeam. And so I just wanted to show you a sneak peek at what that looks like. It came with a software upgrade that we took in January. And the user interface saw some cosmetic changes, a new revamped GUI, which is pretty intuitive to work with. The backend on the database side got some upgrades. Those are obviously harder for you to see, but they did happen. And then something that we really like is there's automatic creation after export from ARIA. And so it pops into the screen, there's a little circle that's half filled, and so it triggers you to know, oh, I can go in and make the ROI. And so that's been nice. It also came with some new ROI drawing tools. One's a freehand tool, so you can get really crazy with your patterns. But beyond that, it's been, there's also improved skin tones, so there's a higher range. And then one thing that we really liked is that it comes with a session-only capture. So this is really useful for our SRS treatments where we're going to take a new reference image in the very first treatment, and so we don't want to keep saving that. So yeah, we've been enjoying the 6.1 features, and we've definitely seen improved stability with the ACO. So thank you guys if you have any questions.